Today's topic is vapor compression refrigeration system. That is simple VCRS. Simple VCRS system is improved type of air refrigeration system in which suitable working substance termed as refrigerant is used. It condenses and evaporates at temperature and pressure close to the atmospheric condition. The refrigerants usually used for this purpose are ammonia, carbon dioxide, and sulfur dioxide. The refrigerant used does not leave the system, but it circulates throughout the system alternately, condensing and evaporating. In condensing, the refrigerant absorbs its latent heat from the brine. Now, brine is a soft salt water which is used for circulating its surrounding the cold chamber. While condensing, it gives its latent heat to the circulating water of the cooler. The vapor compression refrigeration system is therefore a latent heat pump as it pumps its latent heat from the brine and delivers it to the cooler. The vapor compression refrigeration system is nowadays used for all purposes of refrigeration. It is generally used for all industrial purposes, from a small domestic refrigerator to a big air conditioning plant. Now we will see the mechanism of simple VCRS system. The simple VCRS system consists of four components, that is compressor, condenser, expansion valve and evaporator. Compressor. The low pressure and low temperature vapor refrigerant from evaporator is drawn into the compressor through the inlet or suction valve where it compresses to a high pressure and temperature. This high pressure and temperature vapor refrigerant is discharged into the condenser through the delivery or discharge valve at B. Next is condenser. Condenser means cooler. Cooler consists of a coils of pipes in which the high pressure and temperature vapor refrigerant is cooled and condensed. Means the heat is absorbed from the refrigerant. The refrigerant while passing through the condenser give its latent heat to the surrounding condensing medium, which is normally air or water. Third component is receiver. The condensed liquid refrigerant from the condenser is stored in a vessel known as a receiver from where it is supplied to the evaporator through the expansion valve or the control valve. Next component is expansion valve. It is also called throttle valve or refrigerant control valve. The function of the expansion valve is to allow the liquid refrigerant under high pressure and temperature to pass at a controlled rate after reducing its pressure and temperature. Some of the liquid refrigerant evaporates as it passes through the expansion valve, but the greater portion is vaporized in the evaporator at the low pressure and temperature. And last is evaporator. An evaporator consists of a coil of pipes in which the liquid refrigerant at low pressure and temperature is evaporated and changed into vapor refrigerant at low pressure and temperature. In evaporating, the liquid refrigerant absorbs its latent heat of vaporization from the medium. The medium may be air, water, or brine, which is to be cooled. As is shown in PS diagram, if we have to plot the four different points beginning from the compression. Now, if we plot the point number 1, that is low pressure, low temperature vapor refrigerant, then it is the lower pressure point from where the compression process is started. 1 to 2 is the isentropic compression in which entropy remains constant throughout the process. When the compression process is started, the refrigerant from low pressure to low temperature is get compressed to high pressure, high temperature as shown in the pH and TS diagram. The after compression process is shown at point number 2. At point number 2, the condition of refrigerant is high pressure, high temperature vapor refrigerant. Now, after compression, the condensation process is started. In condensation process, cooling is done where the heat is absorbed from the refrigerant and it gets cooled. So, in this process, that is condensation process, the pressure remains constant, only the temperature get decreases from point 2 to point 3, from saturated vapor to saturated liquid points. Okay. So after condensation, the process is shown, that is point number 3, where the vapor refrigerant it gets converted to liquid refrigerant. Means at point number 3, the condition of refrigerant is low, that is high pressure, low temperature liquid refrigerant. After condensation, there is an expansion process in which pressure get dropped from high pressure to low pressure. So this is the vertical process in which the pressure get decreases from 3 to 4 as shown in the PS and TL diagram. At point number 4, the condition of refrigerant is low pressure, low temperature liquid refrigerant, and it is shown at point number 4. Now 4 to 1 is the expansion process in which heat is added to the refrigerant, due to which the phase changes from liquid to vapor, and this shown is by the points 4 to 1. And at point number 1, the initial process is started. Thank you.